Good morning and welcome. My name's John Wetherill. I'm with Activestate based out of Vancouver. I'm a developer evangelist focusing on Staccato, our platform as a service offering. It's a private platform as a service that allows you to accomplish what public platforms as a service, PaaS products offer, like Heroku and Engine Yard and Google App Engine. However, you can run your PaaS on your laptop or on-premise behind your firewall. And today I'm going to run through a brief discussion of that and then run through a kind of a demo of how you can use a PaaS offering to rapidly facilitate your development efforts, whether they're at a small startup or a Fortune 100 large enterprise or anything in between. My background is a software developer. I recently joined Activestate as a developer evangelist based on the strength of the Staccato product, which I discovered about 1.5 years ago. I've been in the past, I was at Sun and Next and a couple other places, University of Alberta. So just to provide some context here, we don't have a lot of time for this demo. I could actually spend 4 hours talking about this. Platform as a service sits between the infrastructure layer and between that and the SaaS layer, the application layer. Platform as a service is targeted at developers and it streamlines the entire software development lifecycle. So it's targeted at developers, but it's useful for QA, for anybody testing the app, for the deployment team, for production, for basically the whole SDLC is greatly facilitated by the use of a PaaS offering. Now, we are a private PaaS, meaning you can run this thing behind your firewall, as distinguished from a public PaaS, as I mentioned earlier. You've probably been watching these acronyms popping up all over the place, sort of, hardware as a service or database as a service, logging as a service, sysadmins as a service, lawyers as a service. They're popping up all over the place. And, this is just the cloud movement. And PaaS is one of these things, but it's slightly different in that platform as a service is used to build SaaS applications. And it's highly useful for doing so, as I hope you'll see during this talk. Platform as a service, I always put up this slide because it kind of illustrates the state of the world as I see it, and as a lot of people do. It's kind of like this wave that's forming offshore. It's a few hundred miles out maybe, but it's rapidly approaching. And so far, the adoption, we're at the very beginning of the adoption curve right now, but it's expected to be huge to the point where PaaS will be considered as essential a tool for developers as source code management is today. Almost everybody's using source code management. Not many are using a PaaS yet, but they will be. And Paul Moritz, CTO of Pivotal, recently said that platform as a service, private platform as a service, will be as influential on software development as Linux was 20 years ago and continues to be today. I think he's understating that fact personally. PaaS, I really think it has huge potential. So what is it? Well, I said earlier it sits between the infrastructure layer or it sits above the infra layer and allows you to build software applications, cloud applications. So at the bottom here is a representation of the infrastructure layer. In our case, we run on pretty much any infrastructure, whether you're using the VM, any of the VM products for hosting your VMs, or you're using OpenStack or CloudStack or Cloud Platform, or any of the Eucalyptus, whether it's running behind your firewall or running out in the public cloud. So you can run this on rack space, you can run it on AWS, or you can run it on your laptop or run it on a rack or a series of racks behind your firewall. Some of the things it provides to developers, well, it provides most of what common services language and runtimes are used for building applications in the cloud. So there's a small sampling of what is available here. So here's the infrastructure layer, and then Staccato sits on top. You as a developer might be a Java developer using Spring and MySQL and let's say a messaging system like RabbitMQ. If you have an app like that, you can take it and deploy it to Staccato with very little, if any, effort. You can just push it out there. Staccato will take care of provisioning the application, finding all the dependencies and wiring those up or hooking those into the app, and then finally provisioning your data services like MySQL or MongoDB. And some of these icons represent some of the things that are provided with the PaaS, but basically if you're using Java or Ruby or JavaScript or Perl or Python, or basically the common enterprise languages, .NET to some extent. And then if you're using any of the frameworks associated with these, like Spring or Play or Ruby on Rails or Django with Python, Node with JavaScript, this all is bundled with the PaaS. So if you have an app using any of that stack, you just push it out. You now can deploy your application to the cloud, regardless of where the cloud is. This kind of illustrates that. So I've got my application, I'm developing it on my laptop, but I'm not actually deploying it to my laptop itself. I'm deploying it to the PaaS that is running on my laptop, which is providing this unified view of the world to the developers, which is the same whether you're on your laptop or you're on AWS or you're on your data center. So this illustrates that. Take my app and I can push it to Amazon, vSphere, HP Cloud, which is OpenStack, Rackspace, which is also OpenStack, pretty much any infra layer. The advantage here, one of many, first it provides a unified view to every developer, every deployer, every tester, QA. It also makes sure that every instance of your app that's deployed to the cloud is identical. Every company I've worked at, one developer has a slightly different configuration than another one. And it's hard to discover this, maybe until it's late in the game and you discover it as you're about to go live. Or even worse, if QA has a configuration inconsistency, that'll cause tremendous problems, often not discovered until it goes into prod. So you got an identical, homogeneous view of your entire cloud, regardless of where your cloud is. Here's a brief overview of what the PaaS contains. This is based on the Cloud Foundry architecture, another very popular private PaaS. There's a few other ones. But this kind of covers the concepts. So everything in the blue box is representing the components, services, and things that are bundled with the PaaS that come with it. It's delivered, by the way, as a VM appliance, meaning you boot it up and run it. And so you boot up a VM and you have access to all this. There's a router involved which takes care of directing traffic to the appropriate applications and app instances or the PaaS itself. The cloud controller is the orchestrator of this entire thing. It sits behind a REST API and is used to manage and control and access your platform as a service and all the apps running on it. There's also a health manager that keeps track of the system and makes sure that all the services are performing correctly, that the performance is okay, everything's running and responding. If it isn't, if something goes awry, it can take action to restart an application or maybe spin up another VM or a new app instance. The stager is used to basically grab the bits for the application and manage the dependencies and wire up services. And these are the services down here. There's message brokers, database services, including the RDBMS systems like MySQL and Postgres, and access to Oracle, or newer database systems like MongoDB or Redis, all available as part of the PaaS. We also offer a shared file system. It's a little tricky in the cloud to deal with file systems because your app instances might be coming and going across your data center. If they're talking to a file system, you have to make sure it's performing or doing what you expect it to do. Presumably, persist some data on a file system that you can access from another app instance or something. We provide mechanisms to make that a lot easier. These things that look like Rubik's cubes are representing VMs that run applications. We call them DEAs, Droplet Execution Agents. They're VMs that run apps, and the apps are placed in what are called LXC, or Linux containers, which isolates each app instance from every other one. It allows you to achieve maximum resource utilization of your apps. So that's the architecture, sort of an overview of the architecture. What I'm going to do now is just show you, I've just been talking, you actually haven't seen it in operation. So let's run through the app itself. I'm always open to questions, so interrupt me if you have any. So, as I said, we offer Staccato as a virtual appliance. You could go to our website and click the download button, and you'll see you can download a free microcloud. This is the cloud that runs on your laptop. You'll see it's available for VirtualBox, VMware, KVM, and a few others. And so what I did earlier is I downloaded the VMware Fusion version of Staccato, and I booted it up. And when I booted it, it showed me a console like this, like you expect when you boot a VM. I can log into this and type and manage it from the command line, but you'll notice it also provides a URL I can use to access the paths. So I go to my browser again and I type in that URL, and you'll see that I can access the paths itself by typing that URL. It happens to remember one that was in my history. Now, previously I'd created a user for this. It's a simple step, but FYI, I've already done that step. So I'll just use that as my credentials. So I type in my credentials, and now I'm logged in to the paths that's running on my laptop. Okay? I'm now at a stage I can deploy apps to the cloud in my laptop. I'll show you a quick way to do that. I go to the App Store. This is a catalog of apps that we provide. It's basically just a list of apps that are hosted on GitHub that you can deploy instantly to Staccato. Now, you can qualify this list or narrow it down by choosing, let's say, just Node.js applications. Here's a handful of Node apps you can deploy. Or let's say you're a Perl developer. Here's some Perl apps you can deploy. Java. The question? Limitation for the microcloud. So the question is, what's the limitation for the microcloud? I assume you mean licensing, how much memory? Okay, so you can put as much memory in this thing as you want. We have a license that kicks in after 4 gigs, but you can have hundreds of gigs or terabytes. RAM, only RAM, yeah, we only license based on RAM. So here's a bunch of Java applications. Jaspersoft is an analytics, Jenkins, but the point is here I can now, I'm going to use a lightweight app here written in Python because the network's here a little slow. Here's a bunch of Python apps. I can click install under currency converter, and it shows me, well, this app's going to be allocated 128 megs of RAM, and it's going to use Redis as a data service. So it's a full stack Python application, and I'm going to deploy it with a click. So now I'm going to choose a name for this. I can call it whatever I want, like water bottle or something. And I click install. So the stager, which you saw earlier here, the stager over here is now gathering the bits for the application from GitHub, checking any dependencies and gathering those, provisioning the Redis service, wiring the application up to the Redis service, and running it. So it's all done. Now the app is running. You see it says here, it shows the app is running. It's a Python app. It's got 1 instance currently. It's allocated 2 gigs of disk, 128 of RAM, 256 6 file descriptors. At the bottom, it shows a list of every app instance running, and here's a URL for the app I just deployed. I'll click that URL. I'm now running this app in my browser, but it's in the cloud on my laptop. I don't know if that makes sense, but I've got basically a cloud running on my laptop, which is running this full stack Python app. It's a 3 or 4 tier app. Includes the front end, the middle tier, the database, whatever, the whole thing. Now this is a simple app. Presumably in here somewhere it's calling SOAP or something to determine the current currency conversion rate. So it's a pretty simple app, but it doesn't matter. You could have a highly complex multi-tier Java, multi-language, Java and Ruby and Perl stack of applications and push them out to the cloud in very few or one operation. So now I've got this application running. It's called Water Bottle. You notice the URL it created was waterbottle.the host name. It took care of all that for us. Now, let's say that I'm about to announce this to the world on Hacker News or Slashdot or on some big site. So I'm expecting I'm going to get 1 million users in the next day. And this one little app instance isn't probably not capable of handling these millions or whatever, tens of millions of users come in. So in the old days, I would have to deal with this and make sure I've got all my VMs and apps deployed and load balancers and everything I need. Nowadays, if I anticipate this event coming up that's going to result in a large amount of traffic, I can click this button and you'll see it allows me to increase the number of instances of this application simply with a pull down. So I click 4 here, or choose 4 and click save. Now instead of 1 application instance, I have 4 running in the cloud. And you'll see if I go back to the applications, or if I reload this page. So it says it's in 75% health. That's because it's spinning up each of these app instances. It's usually very fast, but I'm on a slow network here today. So now all 4 app instances are running. You'll see them listed down here. Now if I go back to the app itself, and if I'm reloading this page, you won't see anything different, but every time I reload the page, I'm probably hitting a different instance of my app because it's being load balanced by the router here. So I've got now 4 instances of my app running in the VM, and the load balancer is directing the requests coming in. It's load balancing around robining between each app instance. Yes? I can't hear.
What happened when you click?
So the question is, what happens if you click the 5th time? So it's doing a round robin, so it just chooses app instance 1, 2, 3, 4, 1, 2, 3, 4, it just cycles through them. But I could have 150 app instances, and it'll load balance between every instance itself. So the point is here is I had to do very little. I downloaded a VM, I booted it, I deployed my app, and then I clicked multiple instances. And that was it. And I have this whole large, complex, scalable application instance at my whim with 5 minutes of work. I've done this a lot in the past where it takes me a month of work or 5 months of work to get this kind of set up. So it's really nice to just have it all automated. Now, the next thing I want to mention is we have a single Staccato instance running on my laptop here. I'd like to introduce the concept of clustering, where you can boot up multiple instances of your PaaS, and they would all join a cluster and collaborate to provide you the resources and services you need. We have Staccato hosted out in on AWS in their data center in Virginia. If I could type, I'll get to it. Data center out in Virginia. So this is Staccato running out there. I've just accessed the URL to manage it. You'll notice that other than the slow network here, the interface is exactly the same. So from the developer's point of view, or QA, or the deployer's point of view, or whoever, I've got the same view of the world. So I no longer have to worry about the infrastructure. I don't even have to think about the infrastructure layer. Someone else can deal with that. They just give me Staccato and I'm done. Now, I did want to mention clustering. So on my now I'm back on my laptop instance, and I mentioned about having multiple Staccato nodes collaborating. This is just a single node. It's one VM instance. Here's its internal loopback IP address to identify it. And all of these roles are being performed by this one instance. So there's the cloud controller, which is the orchestrator of this thing. There's the shared file system I mentioned earlier, the memcached and MongoDB, MySQL, Postgres, RabbitMQ. All of these services are being provided by the one Staccato instance running on the laptop. Now I go back to the AWS instance of Staccato, and I hit cluster admin. And this page will show me similar information, but for the cluster that was built out on AWS. So if I expand this, it'll show me there are 11 VMs, 11 nodes that are participating in a single cluster, single PaaS cluster. And it shows me what each node is doing, what roles it's performing. So this bottom one, identified by its IP address, .66 here, 68, there's the cloud controller, and the router is down running a NAT VM. And then I look up here, number .55 here is running the cloud controller and the stager that builds the apps. And then I go up here and look at 211 here, it's running the cloud controller and the stager. And I thought I had another router here. The point is, I can create I can provision multiple component instances for high availability and redundancy. And this is all easily configurable through the web interface. So I click the configure roles to enable and disable the services that each node is providing. So for example, if I'd like to add a new router to this cluster, I could just enable a new router by clicking this button. I won't do it now, but the point is it's easily available. So you're able to cluster multiple Staccato instances together, and then the sum of all the resources that these nodes provide are available for your applications. So if you need a lot of app instances that each consume 2 gigs of memory, let's say 1,000 app instances, you would just cluster a bunch of Staccato nodes together to provide you all that 2 terabytes of RAM or whatever. I don't know what the numbers are. So that's basically the clustering side of Staccato. I'm going to show you a couple more things and then pause for questions. We support users and groups. I'm in fact going to go back here. So you can create users for your developers and your QA and your anybody deployers, anybody that needs to deploy the app. And you can assign to these users limits, resource limits. So for example, I'm going to grab this user here, JDW, and I'm going to click the user limits button, and it says, well, this user can use 2 gigs of RAM in total, 10 services, 15 apps, 4 URIs, and 2 log drains. And also, this user does not have root access on the actual app containers. So I can specify any of this if I want, just by editing. You know, if I want this user to have 12 gigs instead, I can just do that. It's open-ended. It can be 100 gigs or a terabyte or whatever. I could give admin privileges, change the password. The other concept is groups. So typically, in an enterprise, you would have a QA team of 5 or 20 people. You would put them all in a QA group and then assign to that group specific limits. So everybody in QA gets, you know, let's say 6 gigs of RAM. And so it allows, because I know QA is going to be fairly resource heavy, but my front end team, all the JavaScript, HTML folks, probably don't need much RAM at all. Maybe they just need 1 gig. So this allows me to very precisely manage the resources of my entire data center or my entire EC2 cloud, basically. Making sure that one user can't access more memory than I dictate, making sure that every app is restricted to the amount of memory that we allocate. Could you repeat that? It's hard to hear.
So, in the case of working like with VMware, then you would set that parameter, and then it would set that through VMware.
Yes. Yeah. So basically, the question is, I'll paraphrase. It's the integration between Staccato and the infrastructure layer. When we need to do things like add more resources, we talk to the infrastructure layer to spin up new VMs, etc. So that's the users and groups. The last thing I'm going to mention, and then we'll buzz into questions. The health monitor is keeping track of the whole state of the whole system. And again, I'll go to the AWS hosted instance. What am I looking for? And you'll see that you can get an idea of what's going on, what resources are being consumed. You can see the peaks and valleys and spikes of the usage. And the point I want to make here is that we expose a REST API that you can access from any HTTP client that's on the network to manage and control Staccato. So you can have a command line interface. We have a command line interface client that you can run commands on to access Staccato. Or you can build your own using a shell script that calls curl, which invokes HTTP requests, basically. There's also available plugins for common IDEs like Eclipse and IntelliJ and Komodo. So the developers that are using Eclipse would be building their applications in Eclipse. They would click a button and it would deploy it to the cloud of their choice. They don't even have to exit their IDE to get this working. There's a few other things which, if I had time, I'd dive into, like our logging integration. So I'll mention it briefly. Logging is it's kind of a pain to deal with logging with these distributed apps because you've got log files being generated all over the world, perhaps. And Staccato, instead of you having to deal with that yourself as a developer, Staccato will aggregate all the logs and allow you to pipe them into a logging aggregation service like Splunk or Loggly or a number of other ones. So greatly facilitates that. Same with monitoring, same with debugging. There's a number of features that allow you to, as you've seen already, high availability, set that up, and security. All these things, they're kind of buzzwords, but they're all required for properly deployed cloud applications. And from my point of view, as having developed a bunch of cloud apps in the last few years, if I had had access to a PaaS for those years, I would have saved weeks or months of my life. And so I'm now quite motivated for all my future development to use something like this. So I've just been given a 2-minute warning. So are there questions that I can answer right now? Any additional ones? And I'll say that we're in booth number 321, I think, and I'll be there for the next 2 days. Come by and I can give you a USB stick or a demo or t-shirt or whatever. And yeah, so you had a question?
I'd like to say something.
Okay. Yes.
What's the recommendation? What things I'm not aware right now? The concern. I mean, beside all the advantage.
Oh, good point. Okay. That's a great question. So the question is, what are the downsides, right, of using a PaaS? So here I've been giving you this, sales pitch kind of. What's the downsides of using a PaaS? So first of all, if you've got legacy applications that aren't yet designed for the cloud, for example, they're not really ready for scaling. They might hold on to state. They're not stateless apps. There could be challenges to put it in the cloud and scale it out that way because each app instance is holding on to state and the requests coming in might, go to the wrong instance of the app. So there's some architectural limitations that you'd have to overcome or at least understand before deploying to a PaaS. Another, downside is there is overhead involved. There, the PaaS itself requires memory and disks, or you're using a little more of that. But the counter argument, there's two. One is you're able to pack your apps on more to each instance, and the savings in developer time is enormous. But anyway, downsides. I know there's a couple more, but they're not coming to me. Let me think about it for a sec. So the question is lock-in. So if you spend all your time building your app, this is, I assume what you're saying. I built my app and I deploy it to Staccato, but now it's like, no, I don't want to use Staccato. I want to use OpenShift or I want to use Cloud Foundry. So first of all, we are a Cloud Foundry derivative. So if it's a Cloud Foundry PaaS, we are compatible. If it's another one like OpenShift, there are some differences, and it just depends on the app itself. There might be no configuration required, or if there's some complexity in how it forwards network traffic or deals with the file system, you might have to configure it. But generally, it's all involved. It's all described in a deployment descriptor that's fairly easy to specify. I need this service, I need these ports, and there might be syntax differences, but it's fairly straightforward. Okay, I'm out of time. I'm in booth 321. Please stop by and I can dive into any questions you want. Thank you.